Morning class. Today's video we're going to go over graphing y equals ax squared, which is actually the parent function for a quadratic, and y equals x squared plus or minus k, which is going to be adjusting the y value. So the whole point is for us to see the changes that will happen to a quadratic when we start to do a few adjustments. So the first thing, it says, using your calculator, graph the parent function y equals x squared and complete the table of values. Now, if you do not have this calculator at home, you will need to use your calculator app. I'm just going to use this calculator on the notes today. So we need to go to y equals and just type in y equals x squared. We hit graph. That's what the graph looks like. Now let's go to second graph, and that will pull up our table. And let's fill in all of these values over here. So at -2 needs to be the value 4, -1, 1, 0, 0, 1, 1, and 2, 4. Now let's graph that function here. So our vertex is at 0, 0. And then we have another point. We'll just go left, right. -2, 4. So -2 up 1, 2, 3, 4. Next point's -1, 1, -1, 1. Then we have 1, 1, and 2, 4. And you should see these points mirror each other across the axis of symmetry, which is going to go straight down the y-axis. So this is a sketch of that graph. So this is the parent function. They call it the parent function because there's been nothing added, subtracted, nothing changed to it. It's just our x squared. This is our base quadratic. Now it says graph the following functions, and it asks how the graph of y equals x squared changed. So go back to your y equals, and this time we're going to type in on number 2, 2x squared, and then on number 3, 5x squared. So we hit graph, and let's look and see what happens. So the red line was line 2, and you see it got a little thinner. The black line was line 3, and it got even more thinner. So what do we notice? As the coefficient of x squared gets bigger, the parabola gets narrower. This is called a stretch. So it goes from something like this, where it's kind of wide, to something like this, where it starts getting real skinny. And we can see that happening. The blue is our x squared. It was a pretty wide one. And then the red one was 2x squared. And then the black one was 5x squared. Every time the number got bigger, the graph stretched, or it got thinner, and it went higher faster. Now it says look at the table values change. So we're going to go into our table. So second graph, pull up the table. Now we already have the blue one done. Let's move on to the red one, which is 2x squared. So at -2, this is 8. This one is at +2, 0, 0, and then 2 and 8. At 5x squared, this one is at 20, at 5, 0, 5, and 20. So we want to see what changed about each one. based on the original? Well, the original, which is in blue, you can see from 4 to 8, that's 4 times bigger, right? 4 to 8, that's 2 times bigger. 1 to 2, that's 2 times bigger. 0, 0, don't change. 1 to 2, that's 2 times bigger. 4 times 2 is 8. So each time the y values increase by 2. And we'll say factor so we remember it's multiply. But our vertex, it was still at 0, 0, so this one didn't change. Now, on 5x squared, if we compare the blue one over to the black one, it goes from 4 to 20, 1 to 5, 0, 0, no change, 1 to 5, and 4 to 20. So 4 times 5 is 20. This is also my coefficient there. So each time here, the y values increased by a factor of 5, because all of these are 5 times bigger than what we started with. But once again, our vertex didn't change. It's still at 0, 0. So let's think of what we can say if when the coefficient is 5, it increased by a factor of 5, and when the coefficient is 2, it increased by a factor of 2. What's going to happen to our y values? Alright, so here's what you should write. When the coefficient changes, comma, the y values are multiplied by the coefficient. So all that means is since my coefficient is 2, all my y values are 2 times what they would have been from the parent function. When the coefficient is 5, all of these are 5 times what it was earlier, what it was against the parent function. I'm going to stop the video here. We're going to keep going on the next one.